we all want our monoliths to be full of stars, right? Because that's how they're best. What do I mean by, I can't use that. What do I mean when I say a monolith? And what I really mean when I'm talking about monoliths, I'm talking about 12-factor apps. I'm talking about single applications that do a bunch of different things. They're the kind of apps that we wrote for a long time and that a lot of people continue to write. And there's really, intrinsically, there's nothing wrong with these kind of apps. The purpose of this talk is not to say, hey, you need to break everything up into microservices because microservices are awesome. Microservices are just different. But these monolithic apps, and for years and years and years, we said that was good. Monolithic apps are great because they're close together, they're fast, they're speedy, they do all these things. The problem is that occasionally monolithic apps suffer from bit rot, and they get hard to maintain, and they do things that make it less desirable for us in a lot of ways. And so we want to move to microservices, right? Everybody here wants to move to microservices? Of course. No, 12-factor apps forever. No, seriously. The good news about what I'm talking about is 12-factor apps are great when they're yours, but what if they're somebody else's? What if you're on a team with other people who have other ideas about things? Is anybody on a team with people who have ideas? No, only a few people. Good, good. Yeah, so if that 12-factor app isn't yours and you have to modify it, what do you do then? Don't worry. This is a perfect place to bring in microservices. So microservices are talked about all the time now. Everybody's talking about microservices in Docker. Microservices, really, there's no standard on what a microservice is. There's no governing body around microservices. When I talk about microservices, I'm talking about microservices that really have a few features that we can define them as microservices. And one of them is they're part of a cluster of services, which makes them composable. And that composability is an important aspect of effective microservices. And another thing is that they're small, hence the word micro in them. If you have a microservice that does more than one thing, maybe it's not a microservice, it's just sort of a tiny, normal, big service. And the other thing is, I don't know, the language only gets worse as we go along because there's so many words that are overloaded with other things. But another thing about microservices is they can coordinate with other services and they're discoverable. Now this should sound, if you've done any sort of object-oriented programming, some of this should sound really familiar. Composability, substitutability, something about solid. That's really all we're talking about, but we're applying it now to services, which is where the new part of it is. Anybody think that sounds hard? Nobody? Oh, I totally want you guys on my team. Yeah, it's not hard. Go ahead. 2 weeks. Right? No, it is hard. But there's more good news. You can build microservices on a serverless platform, which sounds great. It's serverless, which means there's not even a server. As a programmer, and I do a lot of ops work, even in my programming, but I don't wake up in the morning and I say, you know what I really want to do? I want to coordinate services. That's real. I was born for that. No, I want to write code. So serverless sounds great. There are a lot of serverless platforms out there. Amazon Lambda is probably one of the best known. Google Cloud Functions. And there's no server, so we just take a function and we call it and we get stuff. Sounds awesome, right? This is where the darkness starts. Okay, there is no cloud. It's just somebody else's computer. Okay, serverless. There's a server in there still. Serverless itself isn't serverless. Any of you heard of INetD? I realize I'm dating myself now. Now I'm the old guy. INetD is really old. You can Google it. So INetD has been doing this for a long time. Small services people have been doing for a long time. Corba was supposed to free us all years ago into a great new world. I think even SOAP was supposed to do that, although I don't know exactly what it does. Except it paid my mortgage for a long time, tearing out SOAP services and replacing them with REST, or as I call it, the consultant full employment technology. You can have fine-grained billing with serverless too, which is also a big deal. If you have to spin up a virtual machine that bills by the hour for everything you do, all of a sudden cost starts factoring in. And cost really isn't something in the future that no matter where you are as a developer, you're going to have to start thinking about cost, which I know is a giant sad. But cost as a constraint gives us a new way to look at things and to make trade-offs, you can use that word with your project managers, trade-offs, about what we want to do and what we're actually going to do. Another thing with microservices, they're distributed. And they're distributed because they're all small and they're distributed by default. Distributed systems add in some bad things, but they also add in some good things. And they're stateless, just like REST, right? REST APIs are always completely stateless. You never have to log in and get a token and pass a session, no? Okay, no REST jokes then. It's got a huge upside, though, with serverless. It's a much smaller operational burden. In fact, some of the people that are selling serverless things and microservices, they call it no-ops, which sounds awesome, right? Like, we're not just into DevOps now, we're into no-ops, no operations at all. That's why I put up that thing about it's somebody else's computer. There's still operations there. You just don't have to worry about it too much. Microservice providers and microservice systems and serverless systems in general tend to be very scalable. That scalability is not something that can really be downplayed. The ability to decompose a large complex system into a bunch of constituent pieces and measure the performance of each one and optimize them in a sane way, along with the ability to spin them up at a huge rate. One of the things I'm going to be showing today is Openwhisk. You can execute 200-300 actions a minute, or 200-300 actions a second on that system without doing anything as a programmer. That's a pretty big deal. Another good thing about serverless in general is that because they're made up of small pieces of code, they're really easy to write. They're really easy to maintain. I know many of you are Rails developers or just in general, you know, when you open up a file of code and it's got like 10,000 lines of code in it, that's a moment where you just say to yourself, well, you know, maybe I have a meeting. So they're almost always very small. The microservices that I'm going to demonstrate today are all less than 100 lines of code. You can look at them and understand what they do very easily, and then you can compose them together to make much more complicated systems. And that's the small bits of composable code. That's a lot of words. This is where the language starts getting weird too, because you've got Google Cloud Functions for a serverless application and a serverless system with Openwhisk and Lambda. Now it's true, there was a string of sounds there, but if you've never heard of any of these things, it's definitely sort of weird. Apache Openwhisk is one of the ones that I'm going to be showing today. Everything I talk about with serverless functions applies to all of these systems. Apache Openwhisk is convenient because it runs on my employer's platform, which is IBM and Bluemix. It's also open source. You can run it yourself. You can actually, it's really easy to set up. They have a whole Vagrant Ansible thing. You can spin up your own system on DigitalOcean in about less than an hour, and you have your own system. There's Amazon Lambda, which is AWS Lambda, which is also a function as a service system. There's Google Cloud Functions, and Azure has something, but I don't know what it's called. I'm also going to put in a plug. I don't know anything about them, but there's a company called Serverless, which again confuses the situation even more. Serverless is a serverless platform for distributing serverless code. It has an API for handling many of the different serverless providers. Even though the code doesn't work on all of them, you have to write different code for different providers. And it's really hard to Google things about serverless, because if you Google for serverless, you're just going to get a bunch of other stuff. But try and check it out if you can. Okay. Here's the problem. All of us now, we're all one mind, right? Okay. So we're sitting at work, and we have this new super deluxe news service that's out there. And our tech lead walks into the office, and she says, hey, this thing's too slow. You got to speed it up. And you think, okay, I got to speed this thing up. All right. What about it? What about it is important is that it's metered and you can't change the code. So what do? We have to put something in front of it. Now the good news is that we mostly get the same queries over and over and again, over and over again, which means it's an excellent candidate for caching. But there are some other issues with the service as you're looking at it. You find that the base query that you get returns 6,000 lines of JSON. And it's all like pretty printed, and it's a complete like spider's web of nastiness in there. And because it's a news query, we really only want 3 items. We want to know when it was published, we want to know what the URL to the story is, and we want the headline. Because all this is going to do is going to be displayed on a widget somewhere so somebody can see some of these news queries. Because we're going into YC funding territory now for our news service, so this is really important that it be fast. The metering is also sort of a problem because it's 10 cents a query. So if we can make it faster and cheaper at the same time, foosball for the rest of the week. All right, let's make it a little bit faster right out of the gate. Now, this bit of gloriousness is most of the Python code for our microservice being deployed to Openwhisk. And what this is doing is it's connecting to our news service here, and all we do is we have a main function. Seems simple, right? And we get some parameters. And the parameters, all this is handled for you. You really just write, this is the code. You just take the parameters in, you execute something, and you return back a dictionary. And then it handles everything else. So the first thing we're going to do is we're going to take those 6,000 lines of code, and we're going to trim it down into those little bits of data that we want already. And that's going to speed up our wire time. We have mobile clients. We have people on slower links. The download time on that 5K of JSON every time, that's going to speed it up a little bit. But you run this, and you find that it still takes about 2 seconds every time you run. So what do we do now? At first, after crying, we Google and we find Redis. Yeah. Redis gets no love? There you go. Redis is awesome. And it's awesome for a bunch of reasons. And one of the big reasons that Redis is awesome is because it's really easy to manage when you go to a service like somebody that you may know who has an API that can spin up instances of Redis very quickly and give you the credentials. Now, we've already deployed our first microservice, and we've sped things up a little bit. We haven't increased our ops burden at all at this point. By deploying this into a serverless framework like that, it's a very simple, one command deployment. Now it's running, it's trimming down the data, everything is great, but we want to cache it. I certainly don't want to go down to the DevOps team and say, hey, I need a Redis cluster. So I'm going to go to this other service, I'm going to throw in my credit card, and because we're a startup, right? Like IBM's totally a startup. I just put everything on the card. No. Of course, some of you may be thinking, why Redis? Why not Postgres? I hear Postgres is the future of data. So Redis is fast. Redis is super, super fast. And really, this is a cache that we're talking about. So we want to run it as a cache, not really as a database. And so what we're going to do is we're going to take Redis. It's very well supported. The command syntax is very easy to use. It has a huge number of SDKs available. You can run it locally for development. It's fast. Did I mention that it's fast? And it fits into this stateless. It fits into the stateless world by providing a place where we can spawn hundreds of these little microservices, and they're all just going to hit Redis, and they're going to get the cached information. And now it's still stateless. The function is still stateless, but we have caching, and we still haven't increased our ops burden at all. Now, who can tell me what's wrong with this slide? It's in JavaScript. You're thinking, wait, Josh, you put up a slide earlier and it was in Python. That is acceptable as a dynamic language. But now, JavaScript? How are we going to handle that? One of the big benefits of running in a serverless and functions as a service world is that most of them support multiple languages, which means you don't have to fight over tabs versus spacing with Bob anymore, because he can just check in his own serverless action, and you don't have to deal with it. You can do code reviews and just reject it anyway, but it's fine because you don't have to maintain that code anymore. I can continue to write in Python as God intended, and this code can go up as JavaScript, which I'll refactor as soon as he goes on vacation. But the good news about that, like I said, is that this is this sounds really trivial, but the fact that as a developer on a team, you can break up the components of work and pass it around to different members of the team who can work in an uncoordinated fashion and coordinate through APIs. Whoa, that's crazy talk. But even within your own team, without enduring a lot of the kinds of coordination efforts that often come into other things. There's no IDL for this. It's still gonna put out JSON. And so we can chain these all together very nicely. And one of the things this does is this action actually calls the action that we just created in Python. And so now when we hit this action, it's gonna call the first action. And if that's in the cache, it's just gonna return the cache. And if it's not in the cache, it's gonna put it in the cache and return the results. By setting it up this way, what we've done is we've reduced, at this point, this is storing it for 600 seconds, which is 10 minutes. So the cache is gonna last for 10 minutes. So we have reduced the number of queries that are executed against our very expensive service by a huge margin. And maybe we can up that a little bit. And we were able to do it in whatever language any of the developers wanted to do. And while the other slide, there was another small function for dealing with the JSON. This is it. This is all of it. This is 50 lines of code. And in 50 lines of code, once I deploy this, I cut the time for using the service from about 2 seconds down to less than 500 milliseconds. No claps for that. I mean, I realize 500 milliseconds is still kind of long, but bear with me. This was going from 2 seconds to 500. That's a lot. I mentioned fine-grained billing earlier. So one of the things that's notable at this point is that in Openwhisk, your first 5 million actions that execute in less than 500 milliseconds are free. So not only have you reduced your operations burden, but you can actually cut down on a lot of costs by using some of these services, because when you're billing in milliseconds instead of hours, all of a sudden there's real value in going in and tuning things up and making them go as fast as possible. So there we go. All right. I've said some numbers, 2 seconds, 500 milliseconds, blah, blah, blah. That sounds good, right? And I mentioned that we as developers do need to take costs into account. Does anybody watch Silicon Valley? A couple people? Yeah. That show is, I think sometimes the writers have been sneaking into meetings that I've had, because this season they're talking about costs and run, containment and all that kind of stuff. It's like, this is too scary to be real. But anyway, all right. So let's look at some costs. Now let's say in our system, we've got 1 query per second. And I did a spreadsheet, so I save you from having to break out your own calculators and do the math on this. But at 10 cents per API call, with 1 query per second, 6 hours a day for 50 weeks a year, that's going to come out to a raw cost of $2,100 a day and an annual cost of, is that $5 million? That's a lot. This is $500,000. I can't even read my own slides. Anyway, doesn't matter. It's a lot. The reason why it doesn't matter is because we just deployed a microservice that cuts that time down to 500 milliseconds and reduces the number of queries. And so now all of a sudden, our application that costs many hundreds of thousands of dollars now costs $50,000. And if we goose that caching a little bit, take it up to an hour, because realistically speaking, does the news change that much in an hour? Not that much. I mean, and a lot of that stuff you can sort of filter it out because there's some noise in there. But if we goose that up to an hour, our annual cost drops to $150, from hundreds of $1,000s to $50 with 200 lines of code and a microservice. Now, how much would you pay for this? Nothing? $1 million. Seriously, $1 million? We'll talk. All right. I went through that pretty fast, but the things to remember here is that you don't have to attack your monoliths head on, okay? You don't have to, when you're faced with a problem in this current sort of bewilderingly awesome world of cloud services now, you don't have to check that code out from CVS and try and figure out how you can build it on a Mac. You can say, you know what, I'm just going to leave that API where it is, and I'm just going to put a little front on top of it, and that little front is going to be written in something nice, something like Python, and then I'm just going to massage that data back out, and we're going to go, and nobody is going to care about it too much in accounting because it's going to be cheaper, and it's going to be faster. Redis is awesome. How many of you are using Redis in production today? I figured it'd be more, but Redis is awesome. 2 hands. Redis is the solution to many of the problems that you're going to run into. It will also be the cause of the problems for the person that follows you, but with any luck, you'll be a VP at that point and it won't matter. And the last thing is that functions, who's using functions as a service in production today? A couple people. Yeah, this is where I slip into fanboy mode. I really am a huge fan of functions as a service. I've been doing this for a long time. I've been in a lot of different systems. Some of the stuff that's coming out now in functions as a service is the first time that really easy and understandable distributed systems can be built by people who aren't also getting their PhD in distributed systems. I mean, many of the distributed systems before this were what I usually refer to as PhD problems. You know, the tech lead comes in your office and says, hey, I need a fully replicated distributed system, you know, across 4 countries. And you're like, well, that's going to take $1 million in 5 years. You know, now 20 years later, it takes like $1.50 and $20 a month for a Redis server. That's pretty good. Questions? Yeah. Sure. Many of the systems like Lambda and Openwhisk, they market themselves as a function as a service because your interaction with it as the customer are at the function level. So with Openwhisk or with Lambda, you have a function that gets executed on whatever event that you specify and takes in information. And so it's a FAS. Does that? How does that compare to microservice when you use that term? So microservices can be made of functions as a service, or it can just be a small service, like with Kubernetes, or if you're really unfortunate, you're running on Mesos. Microservices is an architecture, whereas functions as a service is usually a product. All right. That's 30 minutes. Thanks.